Hello everyone, welcome to the playlist on particle physics. I am Maruf Ahmed, currently studying physics at the University of Dhaka. The reason that I have decided to create this playlist actually can be divided into two parts. The first part being there's been a request to make a series of videos from where every student who's taken an introductory course in particle physics can be benefited, especially for their examination. The second reason, which I think is more personal, is that I myself am not very adept in particle physics. There's been a lot of holes in my learning process, at least I think so, and by trying to create contents on this topic, I'll probably be able to mend some of those, and the next stages hopefully will probably be a little easier for me. So I take this as part of my opportunities, and I myself am really excited and interested in making contents on this topic. And I hope you will find this very fruitful, either for your courses or for your personal learning, or for good. One of the things that I'd like to do in these videos is to lay out the outline of the contents that I think of paramount importance, and it's just a rough sketch. I might add something new or I might subtract something, and I'm not even sure whether I'll be able to complete this playlist, but at least this is the vision I'd like to have in front of me so that I have a structure in my work. So, outline. So at the very beginning, I'd like to talk about special relativity. Special relativity. Special relativity in this context is of paramount importance and is sort of a prerequisite for this course if you're taking it at any place in your university, especially if you're taking it for the first time. You have to know about special relativity. So even though it's a prerequisite, I will try to discuss it, not probably on the required details, but I'll try to cover what's a very essential part of the special relativity that we'll need to do particle physics and especially relativistic quantum mechanics. So at the very beginning, we'll be talking about special relativity. The next topic that I'm going to talk about is group theory. Group theory. But of course, this is not a mathematics course. We're not going to learn group theory in details, just the important part. But especially what I'll be emphasizing on is the topic of Lie group. Lie group, the special kind of group, and Lie algebra. Lie algebra. And this is very important because this concept occurs in a lot of places in physics and in quantum mechanics, in quantum field theory, even in differential geometry, and a lot of places, and I hope I'll be able to do some justice with these topics. The next discussion we'll be doing will be on elementary classical mechanics, especially but two of its formalisms. One is the Lagrangian formalism, Lagrangian, and the other one would be Hamiltonian formalism. Hamiltonian. And later, as an extension, I'll be talking about the generalization to classical field theory. Classical field theory. The next top for us would be the topic on relativistic quantum mechanics. And most importantly, we'll be learning the Klein-Gordon equation. Klein-Gordon equation, or as we most of the time call it in short, KG equation. And I'll also be spending a little bit of time on talking about the difficulties that comes with Klein-Gordon equation and why do we need a better case. Subsequently, our discussion will land on the topic of the Dirac equation. And we'll be talking about, first of all, the necessity of Dirac's equation, and then the symmetries of Dirac's equation. And this is very important, not only for understanding the topic, but also for examination. And if you don't understand the symmetries, you don't understand the conserved quantities. And how symmetries correspond to conserved quantities, that topic will come up in the field theory classical mechanics part when I mention Noether's theorem. But that's for that time. Let's just look at the contents. And of course, at the very end, we'll be learning about how to solve the Dirac equation, so the solution of Dirac's equation. And of course, we'll also be talking about the limitations of Dirac's equation and why that this equation doesn't work in the sense that we're going to apply it, and how. And as a digression, I'd just like to add that the Klein-Gordon equation and Dirac equation all make sense in the context of quantization. But since we'll not be studying quantization, we'll just have to be content with the idea that both of these equations have their success and limitations. And probably somewhere in the next course in the quantum field theory that you will do, either in your university or in somewhere else or as part of your self-studies, you'll notice that how does all of this comes into play. The next step for us would be the electromagnetism and the gauge theory, and how are they related and what the applications of those theory. And as an extension of those, we'll be talking about the Young-Mills theory, which is, I'll not be going into very much details, but this is something that we should know about when talking about particle physics and the relevant topics. Then we'll be making a jump toward learning about Feynman's diagram. Actually, I should write Feynman diagram, but that's all right. And we'll be spending a lot of time on this topic, hopefully, and learning about how to draw a Feynman diagram for different reactions and how to calculate the amplitudes from those diagrams. Then we'll be talking about the nuclear theory, and in that part we'll especially be talking about weak theory as application in beta decay. And then we'll be moving on to the concept of spontaneous symmetry breaking, and a little bit on Higgs mechanism, and hopefully we'll end with a discussion on the standard model, which is a very central part of learning about particle physics, standard model. So some of these topics might not be what you'll be looking for, and some of the topics that you will be looking for will not be here. In fact, most of the topics you'll be looking for probably will not be here. It's just a very focused course, and its purpose is also to assist a certain group of people to succeed in a certain course. So if any of these videos or any of the parts helps you in any way, I would think that my work has done something good, and these contents do have some value. Thank you very much. Looking forward to seeing you.